Let's reverse time. Not by decades, not by centuries, but by 13.5 billion years. Galaxies shrink, stars fade, the Milky Way vanishes. Even the sun disappears until the sky goes completely black. We've gone back to the very beginning, when the universe was young, silent, and empty. No stars, no planets, no light. Just endless darkness, waiting for the first spark. This is the story of how the first stars were born and how their brief, brilliant lives created everything that exists today. Now, to understand how it all began, we need to step into that ancient darkness itself, the dark universe. Right after the Big Bang, the universe was a very different place. It started as a tiny, super hot, and incredibly dense ball of energy. Then, in less than a second, it began to expand, and it hasn't stopped expanding since. As space stretched, it cooled down. Energy turned into matter, forming the simplest elements, hydrogen and helium. If you could float in the universe at that time, you wouldn't see much. No stars, no galaxies, no light. Just a dark, invisible fog of gas, with tiny specks of something mysterious called dark matter. Dark matter doesn't give off light or energy, but its gravity helped shape everything that came later. It was the universe's invisible framework, the structure everything would later cling to. This period, before any stars existed, is called the Cosmic Dark Ages. It lasted for hundreds of millions of years. The universe was expanding and cooling, completely dark, quiet, and mostly empty. But hidden within that darkness, something was beginning to happen. Tiny differences in density, small clumps of gas slightly heavier than others, began to pull more material toward them. Gravity was slowly setting the stage for the universe's first lights to appear. And that's where things start to get exciting, because deep inside that silent darkness, the universe is about to spark its very first flame, the birth of the first stars, population 3. Over time, those clumps of hydrogen and helium gas grew larger and heavier. They were pulled together by the invisible force of dark matter, which formed halos, kind of like invisible bubbles of gravity. Inside these halos, gas started to collapse toward the center. As it fell inward, it heated up. The more it was squeezed, the hotter it became. Eventually, in some of those halos, the temperature reached millions of degrees. And then, for the first time in the history of the universe, something amazing happened. The atoms of hydrogen began to fuse together. This process, called nuclear fusion, released enormous amounts of energy. And in that moment, the first star was born. Light burst through the darkness, the first sunrise in the universe. Astronomers call these the population 3 stars, the very first generation of stars to ever exist. But these were not like the stars we see today. They were giants, many hundreds of times more massive than the sun, shining millions of times brighter. They burned extremely hot and lived very short lives. While our sun will last around 10 billion years, these first stars only lived for a few million years, a blink of an eye on a cosmic time scale. They were made almost entirely of hydrogen and helium, the only elements that existed at the time. There was no carbon, no oxygen, no metals, just the simplest ingredients. Their powerful light started to push through the fog of hydrogen gas, slowly ending the dark ages. For the first time, the universe wasn't silent or dark anymore. It was glowing. But light always comes with a cost. Up next, the first stars meet their fiery end, changing the universe forever. Let's talk about their violent deaths. The story of these first stars didn't end peacefully. Because they were so massive, they burned through their fuel incredibly fast. Once a star runs out of hydrogen to fuse, it becomes unstable. The balance between gravity pulling inward and energy pushing outward collapses. And when that balance breaks, chaos follows. Some of these first stars exploded in huge supernovae, some of the most violent events in the universe. In a fraction of a second, they released more energy than our sun will give off in its entire lifetime. Others collapsed under their own weight, forming the first black holes, objects so dense that not even light can escape their gravity. But those violent deaths weren't the end. They were the beginning of something new. Inside those massive explosions, new elements were forged. Until then, the universe only had hydrogen and helium. But the intense heat and pressure inside supernovae created carbon, oxygen, iron, and many other heavier elements. Those elements would later become the building blocks of planets, oceans, and even life itself. Imagine every atom in your body, from the iron in your blood to the calcium in your bones, was created in the heart of a star like this. In a way, we are all made from their ashes. The death of those first stars made the universe richer, more complex, and ready for the next generation of stars and galaxies to form. And with those explosions came a new dawn. The universe was about to wake up, bright, colorful, and full of possibility. The cosmic dawn. As more stars began to form, their light spread across the universe. This powerful radiation started to change the fog of hydrogen gas that still filled space. It broke apart the hydrogen atoms, turning the universe from cloudy and opaque to clear and transparent. Astronomers call this event the rayonization of the universe, and it marked the beginning of a new era, the cosmic dawn. The darkness was finally over. Clusters of new stars started gathering together, forming the first galaxies. Gravity pulled them into spirals, blobs, and shapes that would eventually grow into the galaxies we see today, like the Milky Way. If you could watch it from above, it would look like fireflies flickering one by one, lighting up the night. The universe was no longer a cold, dark place. It had become a glowing web of light and structure. Massive stars continued to form and explode, spreading elements across space, creating nebulae, colorful clouds of gas that would one day become new stars and planets. From here, the universe kept evolving, slowly but endlessly. Stars gave birth to galaxies. Galaxies collided and merged, and over billions of years, this cycle of creation and destruction shaped the cosmos we live in now. Let's now move on to the legacy and modern discovery. Only billions of years later, humans finally looked up at the sky and started asking, where did all this come from? Now, with advanced telescopes like the James Webb Space Telescope, or JWST, we're beginning to see answers. JWST can see light from galaxies that formed just a few 100 million years after the Big Bang, meaning we're literally seeing snapshots from the universe's childhood. When we look at those faint red dots captured by Webb, we're looking back in time, to when the first stars were still forming. The light from those stars has been traveling for over 13 billion years just to reach us. Each image JWST sends back is a message from the ancient universe, showing how it all began. Scientists have already spotted some of the earliest galaxies ever seen. Tiny, bright clusters that likely hold the descendants of those very first stars. By studying them, we can understand how the first stars lived and died, how they changed the chemistry of space, and how they made the universe ready for life. It's incredible to realize that everything we know, from our solar system to the cells in our bodies, started with those first explosions. Without the first stars, there would be no carbon, no oxygen, no iron, no planets, no oceans, no people. We wouldn't exist at all. And that's it for today's journey through the universe. If you enjoyed this video, make sure to like, subscribe, and share it with someone who loves space as much as you do.